Hi guys, here is your lesson for sum and difference identities. We're going to start with sine and cosine, and I'll ask that you reference the beginning of 5.4 in your book for the tangent identities, but follows a really similar pattern. So what we're going to do is I'm going to walk you and sort of talk you through a few examples, and then we'll do a few examples together in the very end. So these are the sum and difference identities. I would suggest screenshotting this or writing this somewhere down in your notes. Eventually, the more problems that you do, you'll really commit these to memory. But for now, let's just make sure that we get them in our notes somewhere so that we can reference them. So these become handy when we're looking to sort of evaluate or find the exact value of cosine of 15 degrees. So 15 degrees isn't really one of my nice values that's on my unit circle. So what we can do is we can use this identity, and I can rewrite 15 here. Let's get a bigger highlighter. I can rewrite this 15 as 45 minus 30. And I'm able to evaluate exactly cosine of 45 and cosine of 30. So what I can do is I can go ahead and I can follow my cosine of alpha minus beta, and in this case, this is my alpha and this is my beta. So I'm saying cosine of 45, which happens here and here, times cosine of 30, so I'm just following along with this identity, and instead of using alpha and beta, I am using 45 and 30. So here's 45 and 30. So here I'll just go ahead and fill this in. And then I know what all of these are. I know that cosine of 45 is square root of 2 over 2. Cosine of 30 here, sine of 45, and sine of 30. So I can evaluate all of those exactly. And here I end up getting that cosine of 15, once I go through and evaluate all of this, is the square root of 6 plus the square root of 2 all over 4. Once I multiply these guys together and multiply these guys together, and then the same thing with my numerators. And they do have a common denominator, so we can go ahead and combine those numerators. So let's look at another example. Here I have sine of 345 degrees. So we'll just go ahead and we'll do this one together. So I know that this will end up being sine of 300 plus 45. And I know that sine of alpha plus beta is going to be sine of alpha times cosine of beta plus cosine of alpha sine of beta. And that was from the very first slide that we had here. So now I'm really just going to rewrite this exact piece up here, except instead of using alpha and beta, I am going to use 345. So I can say that sine of 300 times cosine of 45 plus cosine of 300 times sine of 45. And using my unit circle, I can go ahead and evaluate. Sine of 300 is negative square root of 3 over 2 times cosine of 45, which is root 2 over 2, plus cosine of 300 is 1/2 times sine of 45 is square root of 2 over 2. So when I go ahead and multiply these two things together, I get negative square root of 6 over 4, plus here I'm going to get square root of 2 over 4. So I'll end up here with sine of 345 degrees is equal to negative 6 plus square root of 2 all over 4. And that will be my final answer. So one of the trickier parts here sometimes is really thinking about those values that are on our unit circle and thinking about, of those values, how can I use addition or subtraction to come up with 345? So here's another example, cosine of 5 pi over 3. So I want to split this up into pi over 3 plus 4 pi over 3. So that will give me 5 pi over 3. So my cosine identity, I'm adding these two things together. So cosine of alpha plus beta is going to give me cosine of alpha times cosine of beta minus sine of alpha times sine of beta. So again, I'm just going to write the same exact thing here. So I have cosine of pi over 3 plus 4 pi over 3. And so this is my alpha and this is my beta. So here I have cosine of pi over 3 times cosine of 4 pi over 3 minus sine of pi over 3 times sine of 4 pi over 3. And then we'll go ahead and use our unit circle to evaluate. So cosine of pi over 3 is going to leave me with 1/2. This is going to be negative 1/2 minus the square root of 3 over 2 times sine of 4 pi over 3 is negative square root of 3 over 2. So here I'm left with negative 1/4 when I combine these, minus, so negative square root of 3 times negative square root of 3 is actually going to give me plus 3 over 4. So cosine of 5 pi over 3 is going to leave me with 1/2. And if we go back, we can actually see that this is one of our nice sort of values that we know on our unit circle. So we just sort of went back and verified these sum and difference identities. So you have some problems to do for homework. I'd suggest having your unit circle out in front of you as you're working through some of these. And I'm just going to scroll back up to the top right now so that if you didn't get a chance to screenshot or write these down, that you have an opportunity to do so now. Good luck with your homework, guys, and I will see you in class this week.